In this lesson, I'm going to introduce how to construct and do simple operations on matrices. So far, we have really only seen vectors, and a vector can be seen as a one-dimensional object that has a length. A matrix takes that a step further. It's a two-dimensional data object. Each element of a matrix sits at the intersection of a row and a column. In this untitled script, we have a line that creates a matrix. And to create a matrix, you use the matrix function. You have to enter in, as the first argument, the data you're interested in, and the number of rows and number of columns. So let's run this line. We now have in our environment the A matrix. And when I have it output into the console, we can see what it looks like. So there are 2 rows and 3 columns. Now sometimes we want to transpose a matrix, which is pretty simple. And what a transpose does is it flips the numbers around the diagonal. So after we transpose the matrix A, we're going to end up with 3 rows and 2 columns. The transpose function is just the simple lowercase t. Now something interesting is that when you use the transpose function on a vector, it actually turns it into a 1-row matrix. So let's create a simple vector. I'm just going to have it be the numbers 1 through 5. We can use the dim function, which will tell us the dimensions of an object. So when we do dimensions of the vector, it's going to say null because it doesn't see it as a matrix. But now if we use the transpose function on the vector, we can see it has some more structure now. Whereas before it looks like this, now we can see it has 1 row and 5 columns. So if we ask for the dimensions of the transpose of a vector, it will give us 1 and 5. Now, if we want to know what the element is in the first row and third column of a data matrix, we can use the square bracket subset. We just have to give it another argument. So for example, if we want the second argument of the vector I just created, we use the square bracket subsetting and enter in the single digit 2. For the matrix, if we want what's in the first row and third column, for instance, we do 1, 3. What you put to the left of the comma defines the rows that are selected, and what you put to the right defines the column. So if we look at the A matrix again, we can see that this subsetting worked. It returned 4, which is correct. Now, if you try to subset for something that doesn't exist, for example, what's in the first row and the fourth column, it's going to say subscript out of bounds. And this is an error that you may come across pretty frequently. If you're just interested in a slice of the matrix, let's say you want the whole second column, you leave the left side blank and you do 2, and it returns 1 and 1. Or if you want just the first row, you leave the right side blank and put a 1 to the left of the comma. Now, generally, when you make a matrix, you don't always need to specify number of columns and number of rows. Generally, if you specify 1, it will figure out what the other one should be. So let's create a sequence of numbers, and we're going to say n row equals 7. And we're not going to specify number of columns. And it was able to figure out, based on the length of the sequence that I entered and the number of rows, what the number of columns is going to be. If you enter no argument for the number of rows or number of columns, it will just assume that number of columns equals 1. What if you want just the second and fifth rows? So we want to be able to separate this row and this row from the rest. Well, we can use the C function. So we have to put it to the left of the comma, put lowercase c, and then we'll put the 2 row numbers that we're interested in, 2 and 5. Another useful matrix building function is diag. This function creates an identity matrix, which is a square matrix with ones in the diagonal. So if I use the diag function and enter 5, it's going to return a 5 by 5 matrix with 1 at each diagonal. If you do diag 1, it just returns the number 1 in a 1 by 1 matrix. These diagonal functions are very crucial for matrix operations and exist as part of the code in many statistical packages. Mathematical operation works on matrices just like they do on vectors. So if I take my A matrix, I can multiply it by 2, and it will multiply everything in the matrix by 2. I can do the square root of the matrix A, and I can also square it. We can also add matrices to other matrices. So let's create another matrix called B. So now we have 2 matrices, A and B. And what do you think is going to happen if I try to add them together?